Welcome to my kcse revision channel, Marita James, University Boys High School. Kindly subscribe, click the notification bell, you get notified once I upload a new video. Today we are looking at Form 3 work, and our topic is nitrogen and its compound. We are looking a summary of nitrogen and its oxide in one page. So we have nitrogen. This nitrogen, the first step, how do you get it from air? So we have the isolation from air by the method we call fractional distillation. So in fractional distillation, the air is first purified by electrostatic precipitation to remove impurities and dust particles. Then carbon dioxide, which is also a component of air, is removed by passing through potassium hydroxide solution or sodium hydroxide solution. So the purpose of sodium hydroxide solution or potassium hydroxide solution is to combine the carbon dioxide from air. Then we have also water vapor, which is also a component of air. A water vapor is removed by cooling to negative 25 degrees. So when you cool the air to negative 25, water vapor is normally removed. Then after water vapor removed, we have the remaining air, which is compressed to negative 200 and 200 atmosphere. And in this process is a repeated expansion and a contraction. In that stage, repetition of a contraction and expansion and a contraction, the air now will change their state from being gaseous state to a liquefied air, whereby now the nitrogen gas is collected at negative 196. Now, how is this nitrogen being prepared? So we have the preparation of this nitrogen. So nitrogen is prepared through the double decomposition reaction, whereby the sodium nitrate combined with ammonium nitrate to have sodium chloride and ammonium nitrate. The ammonium nitrate in this case now is a stable compound, whereby it will decompose in the presence of heat to have water and nitrogen gas. So that is a simple way on how this nitrogen gas is being prepared. So you react sodium nitrate with ammonium chloride, you will get ammonium nitrate. Ammonium nitrate being an unstable compound in the presence of heat, it decomposes, and therefore we have nitrogen gas. And therefore, we have the properties of this nitrogen. The properties are categorized into two. We have the physical property and the chemical property. In the physical property, the gas is colorless. It is a colorless gas. It is slightly soluble in water, and that is why normally the gas is collected over water. And then we have, it has a boiling point of negative 196. That is simply the physical properties of that gas. Then we have the chemical properties. In the chemical properties, as you can see, that the gas does not burn and does not support combustion. So it does not burn and it does not support combustion. But now it can react with alkalis and alkaline earth metals. When we are talking of alkalis, these are the group 1 elements in the periodic table, and the alkaline earth metals are the group 2 elements in the periodic table. So it can react with the alkali, where it can react with the sodium to form sodium nitrate. It can react with the magnesium. Magnesium is an alkaline earth metal, and sodium is an alkali metal. So it reacts with the magnesium metal to form the magnesium nitrate, and it is also react with the calcium. Calcium also is also an alkaline metal, where it will combine with the nitrogen to form the calcium nitrate. Now what will happen when water is being added to all these nitrates? Ammonia gas is produced. So if water will be added here, you can have ammonia gas. If water will be added to magnesium nitrate, you will have ammonia gas. If water will be added to calcium nitrate, you will have ammonia gas. Now, we have the uses of this nitrogen, gas. The gas is inert, it does not support combustion, and therefore it does not burn. So we say it is used to fill and empty oil tankers to prevent an explosion. That is one use. You can also say it is used in filling tires of an aeroplane due to its inert nature. So it is inert, it does not react. It can be used to fill tires of an aeroplane due to its inert nature. Now, normally we have three oxides of nitrogen. We have nitrogen 1 oxide, we have nitrogen 2 oxide, and then we have nitrogen 4 oxide. So we have this nitrogen. The first oxide we have, it is this nitrogen 1 oxide. Nitrogen 1 oxide now, we can have how it is being prepared. So we have the preparation. It is prepared by heating ammonium nitrate, which decomposes in the presence of heat to sodium, to nitrogen 1 oxide and water. So I said this one here. So how can you test for this gas, the nitrogen 2 oxide, nitrogen 1? When I asked you to describe the test for this nitrogen 1 oxide, you just say, when you are describing an experiment. So you need a glowing splint, and also you need a gas jar, a jar which is full of that gas. And therefore you give a procedure on what's supposed to be done. So you lower a glowing splint into a gas jar full of nitrogen 1 oxide. So what will happen here? The gas relights. So it relights, the glowing splint relights. So simply you can test the gas. It normally relights the glowing splint. So you lower a glowing splint into a gas jar full of this nitrogen 1 oxide, whereby it will relight. Now the gas, we can also have the properties. The properties are categorized into two. We have the physical property and the chemical property. Physical properties of this nitrogen 1 oxide. The gas is colorless. It is colorless, so you can see there. It is colorless. So the gas is colorless. It has a pleasant smell, and the gas is slightly soluble in warm water. So there are these three physical properties. So it's a colorless gas. It has a pleasant smell. It is slightly soluble in water. As you can see in this diagram, the gas is slightly soluble in warm water, and that is why now the gas is collected over water. Under the chemical properties, the gas can react with magnesium, it can react with copper, it can react with phosphorus. When it reacts with magnesium, when the gas nitrogen, this nitrogen 1 oxide gas reacts with magnesium, it forms magnesium oxide. And what are the observation you can make here? The observation here, you can see a white flame, so it burns with a white flame, and then you can have a white solid, and that white solid is magnesium oxide. It can react with the copper to form a copper oxide, and the observation you can make, it forms a black solid. It can also react with the phosphorus to form phosphorus 5 oxide, and the observation you can make here, it is a yellow solid. Now we have another oxide. Okay, before we go to another oxide, we have the uses of this nitrogen 1 oxide. So you can also be asked in an examination, state one use or give one use of nitrogen 1 oxide. You simply say that it is used as an oxidizer in a racing car engine and the rockets. So that is one use. So you can follow KLP and top notch to get more of the uses of this nitrogen 1 oxide gas. Now we have another oxide of nitrogen, which is now nitrogen 1 oxide. In a nitrogen 1 oxide, we have preparation. How is this gas being prepared? So in preparation, it is a reaction between copper metal and nitric acid in this case. So you will be having a copper metal reacting with the nitric acid. So when you react the two, you will form the copper nitrate plus water plus nitrogen 2 oxide gas. So simply that is how the gas is being prepared. A reaction between copper and nitric acid. So you will get the nitrogen 2 oxide gas. Now what are the physical properties? So we have properties which is also grouped into two. we have the physical properties and the chemical properties. So in the physical properties, the gas is colorless. It is a colorless gas. It is slightly soluble in water. So it is a colorless gas, and therefore it is slightly soluble in water. That is the physical properties. Under the chemical properties, it reacts with a sparked hydrogen, forming water and nitrogen. So in these chemical properties, you do more check for the KLP and the top notch and other revision books. So you will get much. You get much of the chemical properties of this nitrogen oxide gas. Now we can also have that we have the uses of this gas, which is nitrogen 2. Nitrogen oxide gas, one use is used in the manufacture of nitric acid. In a process, we call it the Ostwald. So we have, the process is called the Ostwald. It is called as the Ostwald process. So it is used in the manufacture of nitric acid in a process. In that process, we call it Ostwald process. Now, how do you test for this gas? Testing for this gas, when the gas is coupled through a freshly prepared iron salivate, a brown ring is formed. So it normally forms a brown ring. It forms a brown ring with a freshly prepared iron salivate. That is how the gas is being tested. Now we can also have another oxide of nitrogen, which is nitrogen oxide gas. We have this nitrogen oxide gas. The preparation, so of course you can have the preparation. Preparation in this case now is a reaction between copper and nitric acid. So when copper and nitric acid react, when copper and nitric acid react, they can form nitrogen 4 oxide gas. We can also have the properties, which is also categorized into two. We have the physical properties, whereby it is a brown gas. So this one is a brown gas. It has a pungent smell. So it is a brown gas. It has a pungent smell, and then the gas is poisonous. So under the chemical properties, it dissolves in warm water. It dissolves in water, not in warm water. It dissolves in water to form an acidic solution. We can say that it dissolves in water to form it can also combine with the rain in the atmosphere to form an acid rain. So we can have the acidic water. Now, under the uses of these gases, it is used as an oxidizing agent. It is used as an oxidizing agent in a lead chamber during the manufacture of a sulfuric acid. So, this is a summary of one page of nitrogen and these oxides. Kindly follow my channel. I will be uploading the videos on one page summary on large scale manufacture of ammonia and large scale manufacture of nitric acid. Follow my channel, click the notification bell. You get notified once I upload a new video. Thank you.